it could have been worse.
Well, and then I don't understand how derivatives applies to this, because I thought
perfection,
derivatives was slow.
It is. So what we're trying to find maximum and minimum values. So we're trying to find where the slope is 0.
Why do we need that to figure out this box then?
Well, if we're trying to maximize something, we want to find where the slope of that function is 0.
That makes more sense. Then whenever you say maximize
Most of the
something,
people
not just
there had school on Friday, so they were coming. They were like, "Oh, I came from my first period." I'm like, "Ha ha! I didn't do school."
Alright, so let's take a look at some of these problems here. Where do we want to start?
Two I got, but I'm not gonna lie.
Can we just do
I
it?
copied the one that we got yesterday.
I don't know. It's gone.
All of them?
Yes,
Okay.
please.
Alright.
Can you do the answers on a piece of paper, put it up on Schoology?
Yeah, I can do that.
Okay.
But if everybody
That was my
needs help, we can just go through them together here. Alright, so I guess we can just start with number 1. Okay, I sent you guys just to do 2 through 4 on the remind, but I don't know if everybody looked at that or got that.
Okay. I need to download mine again because I got a new phone.
Oh, also, with Remind, if you have Verizon, no, they're just going to stop sending texts if you have Verizon. So what you need to do is download the app so that you get notifications instead of texts. Okay, so if you have Verizon, make sure you download the Remind app so that you get push notifications instead of text messages.
Now you want to be a square.
I still get
Verizon's better. Alright, so number 1. First thing we want to do is draw a picture normally, but for 1 and 2, if we're just finding 2 numbers, there's not really a picture to draw. So I want to find 2 positive numbers such that their product is 192. So product is 192. Well, that means I'm multiplying them together and getting 192, right? Their sum, or the sum of the first plus 3 times the second, is a minimum.
Don't mind me.
I'm way off here.
Yeah, we're doing number 1. So sum means we're adding. So the sum of the first and 3 times the second is a minimum.
I did this.
Right? So these are my 2 equations. Now, this is the one that I want to minimize. So I need to write this equation in terms of a single variable. It does not matter if I solve for x or y. Okay, so I want to take my other equation and get one of those variables by itself. Which one do we want to get by itself?
X.
X? Alright, so I can take this and divide both sides by y and get x equals 192 over y. Right? Now, in terms of solving or taking a derivative, okay, generally it's easier to think about negative exponents, right? So 192 over y, I can write as 192y to the negative first. So I'm going to take this and replace my x with that. So I'll have 192y to the negative first plus 3y equals my function here. Now, if I want to minimize this, I want to take the derivative. So I will have negative 192 y to the negative second.
She's not there.
She's not there.
She's just talking.
She has
Yes, it's teaching right now. We are going over homework. Yeah.
This is like a scary movie.
She's
Whenever
like,
Brenda's on the phone and everyone's
I can't. Do you want to stay for the homework? Like, I don't. You're not gonna be able to hear anything. Do you want to stay for the homework, or do you just want us to fill you in later? No. Do you want us to put the phone up so you can pay attention to homework, or what's the class code? Do you want?
Class code?
What's your
How
class
do we
question?
know that?
Never mind.
Oh, for remind?
Yeah.
I don't know off the top of my head. I'd have to look it up.
I can probably.
Overall.
120 feet for the 3 sides total.
For all 3 sides equal 120.
Yeah.
Okay. So we did it. Ah, she doesn't have that. Okay. That was interesting.
I don't understand it.
So, we took our 192y to the negative first and plugged it in place of x, right? Then I took the derivative. Got negative 192y to the negative second plus 3 equals our derivative. We okay so far? What's that? So, yeah, so we should figure out our domain here, right? So if I have 2 positive numbers right off the bat, I know that they both have to be greater than 0, right? So I can say both x and y have to be greater than 0. Is there a maximum value that they could be?
No.
Yeah, right? They would have to be less than 192. Is it possible that they could be equal to 192?
I don't know.
What do you want to
Yeah, we could multiply 1 times 192, right? So it is possible that they could be equal to 192. Okay? So, now, I want to set this equal to 0 and solve, right? That's going to get my critical points. Now, also remember when we're solving, it's probably easier to change this back to a positive exponent. Okay, so y to the negative second is the same as y to the positive second in the denominator. Well, now, I could add this over to the other side. Cross multiply. Divide by 3. That's 192 divided by 3. It is 64. That's square root. So we would get y equals plus or minus 8. Would both of those be a possibility?
No.
Yeah, negative wouldn't be, right? Because we know both of these are positive numbers. So my only critical point that I get is positive 8. So let's put this on a sign chart then and see if this is a minimum, right? Because we want a minimum value, so we have to check to see if this is a minimum. So I want to take a value less than 8 and a value greater than 8 and plug it into the derivative. So if I take 1 and I plug it into my derivative, negative 192 over 1 squared plus 3. Well, negative 192 divided by 1 is negative 192 plus 3. That's definitely going to be a negative number. If I take a value greater than 8, I don't know, 10, I plug 10 in here, negative 192 divided by 10 would be, divided by 100 would be negative 1.92 plus 3 is going to get me a positive number. So is this a minimum or a maximum? It's a min, right? I'm changing from decreasing to increasing. I think your equations were wrong. to start. Yeah. So we do get a minimum value here. That's what we want. So one of my numbers, okay, my y, is 8. How do I figure out my x? Plug it in. To what? Which one? This one or this one? First one, right? Because once I plug my 8 in for y, I will only have one unknown left here. If I plug it into this equation, I would still have 2 unknowns. So I need to plug it into my first equation. So I'll have x times 8 equals 192. Divide both sides by 8. And what do we get? 24. What? I don't know. Do some mental math, I guess. So the two numbers that multiply to 192, and the sum of the first plus 3 times the second is a minimum, would be 24 and 8. Yeah, so here, I mean, it just says find these two positive numbers. So that's my answer. Yeah, and I think I mentioned sometimes, like on number 4, it says, find the lengths and the maximum area. So we would need to make sure that we're answering what the question is asking. In this case, for number 1, it's just those two numbers, 24 and 8. All right, we okay with that one? Do we want to do 2 as well? It's similar, except we are given the sum and we want to maximize the product this time. Yeah. So the answer's 50 and 25. All right. We okay with that one? Yeah, let's. Yeah.
3? I drew my picture.
That's a good start.
And I came up with 2 equations, but then I didn't know which one to take the third.
Well, that's usually the hardest part, is coming up with the equations. All
I
right,
never
so
said they were right. I just said I came up with something.
okay. So on this one, we are making a rectangular enclosure using a wall as one side. Okay, so this, we can say this is the wall. Right? Here's my wall, and 120 meters of fencing for the other 3 sides. We want to express the area in terms of x and find the value of x that gives the greatest area. So that last sentence may have been a little confusing, okay? But this is exactly like the example we did in class. Right? We want to make a fence that's got 3 sides. I can say that these sides are x, this side is y. Right? I don't know any of those lengths. What I want to do is maximize the area, given that these 3 sides have to add up to 120. Well, what I can say then is 2x plus y has to equal 120. And x times y we want to maximize, because the area of this rectangle would be x times y. So these would be my 2 equations. Now, when it says express the area in terms of x, that's just saying put this in terms of one variable. Right? It doesn't matter which variable you solve for. Right? So I want to take this equation, okay, and solve it for one of the variables. Well, it's probably going to be easiest to solve for y. Right? So I can just subtract 2x from both sides. Say y equals 120 minus 2x. Then I can take this and plug it in place of y in the equation that I want to maximize. And we always are trying to write the equation that we want to maximize or minimize in terms of one variable, because that's the one that I want to take the derivative of. You should probably never get 0 as the derivative. There should always be some variable in the equation that we want to maximize or minimize. So here, it's probably going to be easier to multiply this out before I take the derivative. And just make this 120x minus 2x squared. Now, I can easily take the derivative just using power rule. So I would get 120 minus 4x. Set it equal to 0 now to find critical points. So 120 minus 4x equals 0. Add the 4x over. Divide by 4. We get 30. Okay. So the question says just find the value of x that gives the greatest area. You're probably not going to see a question like this. They're probably going to want both dimensions. So let's go ahead and find what our y value would be. And to do that, plug it into my constraint equation, first equation. So I'll have 2 times 30 plus y equals 120. And we can easily solve for y. And get y equals 60 here. So the dimensions here that would yield the greatest area are 30 by 60. Oh, yeah, I guess we should have. I jumped ahead. We should have done a sign chart to make sure that this was a maximum value. So we would want to put 30 on our sign charts. Plug a number less than 30 into the derivative. Well,
Not 1.
yeah, let's do 1. So 120 minus 4 would be positive. If I choose a number greater than 30, 120 minus 4 times 50, right? That's going to be a negative number. So this, if I'm changing from increasing to decreasing, does give me a maximum. So that is what we want. Greatest area means maximum. So 30 is a max. That is what we want. So then we would plug our value in and get 60. We're going to do an example today where we're going to find that the value that we get, the critical point, isn't what we want. So on this example, no, because you would get the correct answer without a sign chart. However, there are examples where you will find that, like, say this question we wanted a minimum. We find this is a maximum. We need to do something else to find the actual correct answer. Does that answer your question? You okay with this one? Yeah, so number 4 then. Pretty similar, except we don't have a border, right? We don't have a wall or a river or something like that. Here, we're just making a rectangle. Its width is x. Don't know its height either. So I want to find the maximum area given that the perimeter is 8. Okay. So I can write 2 equations. Right? I can say that my perimeter is going to be 2x plus 2y equals 80. And then I want to maximize area. So area would just be x times y. So now I want to solve for one variable in my constraint equation, plug that in here. I'm going to get the exact same thing either way I solve here. Right? So it doesn't matter which one we solve for. I'll solve for y. So we'll get 2y equals 80 minus 2x. Divide by 2, and we'll get y equals 40 minus x. So I can take that and plug that in here. So this will be x times 40 minus x equals m. Again, before we take our derivative, it's probably going to be easiest to simplify. Now taking the derivative, we just get 40 minus 2x. I want to find critical points, so I will set this equal to 0 and solve. 0. So add the 2x over, divide by 2, we get 20. Put this on a sign chart. So choose a value less than 20. If I plug 1 in, 40 minus 2 is positive. If I take a value greater than 20, 40 minus 2 times 21 is going to be negative. So that is a max that I'm changing from increasing to decreasing. So we need to find our other dimension then. So I will take that 20 and plug it into my first equation. So 2 times 20 plus 2y equals 80. So we get 40 plus 2y equals 80. Subtract 40, divide by 2. We get y equals 20. So the dimensions of this rectangle are 20 by 20. So it's a square. Right? Now, we haven't quite answered the question yet. It says, and find the maximum area. So we just need to take our dimensions and multiply them together to get that the max area is 400. And we are given units, so 400 square centimeters. So, an interesting piece that we get out of this question, whenever we are trying to maximize area of a rectangle, it's a square. Okay? Given constraints of a perimeter, right? For example, a fence. Right? If we're given a certain amount of fence, to maximize area, it will always be a square. Okay? Well, we did. Figured that out. Right, yeah. So we had to figure out that it was a square. But this is true if we're trying to create a rectangle with 4 sides. Right? Obviously, we can change it up and say, well, we're only going to do a 3-sided rectangle. And then our answer changes a little bit. Then it's not a square. But if we are trying to create a rectangle with all 4 sides, the maximum area will always be given by a square. Okay? We okay with these now? Make a little more sense? Alright, then let's go back to those notes we were working on Thursday. I think we left off on 3.
We got the first equation. That's about all. It makes no sense.
You're going to be okay.
Don't flick me. Abuse.
Related rates?
Yeah.
Yes.
There weren't any in there. Oh, there were one problem.
8 cylinders?
And I got on our midterm? No, on our packet. There was like one.
Oh, Christmas break. Yeah, there was one related rates problem. But yeah, over Thanksgiving break, it was all related rates. So. All right. So, were we okay with setting up this equation? I guess we can go through a quick review here of what we did to set this up. So we're taking this 18 by 30 sheet. Right, so I know this whole thing is 18 by 30. We said we want to cut out squares that we don't know the dimensions of. So we're going to cut these out and then fold this box up, and we want it to have a maximum volume. So what we did was, well, said I want to maximize volume. The volume of a rectangular prism is length times width times height. So we said that when I cut these squares out, this side of the box will have a length of 18 minus 2x. Right? This side then would have a length of 30 minus 2x. And the height of the box then, once I fold these sides up, the height will be x. So this was my equation. Do I need a second equation? Is there any other information here that I could write an equation with, or do I even need one here? Why would I not need a second equation? Because yeah, exactly. It's already in terms of a single variable. I don't need a second equation if my first equation already only has one variable in it. Okay? So I just want to take the derivative of this equation. Now again, it's probably going to be easier if I multiply this all out before I take the derivative. I don't really want to do triple product. Okay? So let's multiply this out. Okay? If I multiply these two binomials together, what do we get? 540 minus 60x minus 36x. So minus 96x plus 4x squared times x. So multiply that all by x then. Just have to train it to do derivative time, right? So I can just use power rule now. Say 540 minus 192x plus 12x squared. So I did negative 2x times 30 would be negative 60x.
Oh.
And then negative 2x times 18 would be negative 36x. So negative 60 and negative 36 gets me negative 96.
Where did you get 60?
I was thinking, okay, I was thinking 30 minus 36.
We all good?
Yeah.
Alright. So set this equal to 0. I can probably simplify this a little bit, right?
Everything's divisible by 2.
Everything is divisible by 2.
So
Everything is divisible by something bigger than 2.
54 is divided by 6.
Yeah.
So it's 12.
Yeah, I think these are all divisible by 6.
I hear calculators going.
It's 32. 192 divided by 6 is 32.
What about 5? There we go. Oh, that.
So they would still be divisible by 2. So they're all divisible by 12, right?
Yeah.
So go one more time around.
So we can say 45 minus 16x plus x squared. Okay, those are all divisible by 12. So now let's see the factors. Right? That's the easiest way to solve a quadratic. So I want two numbers that multiply to 45 that add to negative 16. Does it factor?
Two negative numbers.
Close, but still no.
That doesn't work at all. Oh, I was thinking of 9 times 5.
So I don't think this one factors.
Quadratic.
So let's do quadratic formula.
X equals the opposite. 16 plus or minus the square root of
Each is squared.
yeah. Plus no minus.
Minus 4.
4 times AC. I'm trying so hard to remember this. And I'm
Over
failing.
2a.
I'm failing so hard. I'm so sorry.
So negative 16 plus or minus the square root of 16.
Wait, it's the opposite, so it'd be 16.
I don't have
So yeah, I don't think this works out very nicely. So let's plug this into the calculator and get a decimal here.
I decided I have negative 45.
By the way, do we need a domain?
Yeah.
See, I don't trust my phone calculator now.
Six. So let's, I think I've mentioned before, but on the AP test, they always want you to go to 3 decimals. So let's go to 3 decimals whenever we round. 641. So let's go back one step, okay, and figure out our domain, okay, before we make a sign chart here. So what's the smallest value that x could be? Yeah, it has to be greater than 0, right? So we can say that x has to be greater than 0. What's the largest that it could be? Almost. Well, no, not 30?
540.
Yeah, oh, you're getting colder. So if we think about this side here, where I'm taking out 2 x's from 18, the largest that x could be
Oh, no.
is 9, right? The largest x could be is 9 because I'm taking out 2 values of x here from this 18. So if I keep making x bigger and bigger and bigger, I'll get to the middle when x is 9. So x has to be less than 9.
So you can knock out.
Right, so we can knock out this one. So let's put this value on a sign chart and see if we get a maximum. So let's test a value less than that. Say 1. If I plug 1 into my derivative, I'll get 540 minus 192 plus 12.
Positive.
It's going to be positive. And if I plug a value greater than that in, you pick anything greater than that but less than 9. So 4 or 5. This one might be a little bit trickier to think about, but if I plug 5 in here, what's going to happen? It's going to be negative, yeah. So we get a maximum, right? We're changing from increasing to decreasing, so that is a maximum. That is what we want. So the question says, okay, it asks 2 questions, right? What size squares should be cut to make the box of maximum volume, and what is that volume? So yeah, so let's take this value. Okay, we know that this is the value of x that we want. Now we want to plug that in to find the maximum volume. Yeah, so for the first part, we can say that the size of squares should be 3.641 by 3.641. Were we given a unit? Yeah, inches. 3.641 inches. So then the volume, we can just take this 3.641 and plug it in here for x. So what do we get when we do that?
I got
So-
1,454.
We would plug it into the original. Say it again.
I got 1,454.
Somebody double check that. What did you get? 86.553.
All over the place.
What was it? I think it's going to be. I don't know. Those. Yeah, I got the 886.553. Feel okay with that one? Sure. Questions?
Wait, how did you get the line again? Like that?
So, if we look at this side here, the shorter side, we know that we're cutting out a piece from both sides, right? So, if I think about making this piece bigger and bigger and bigger, if I meet in the middle, the maximum that that piece I cut out can be 9, right? There's no way that I can overlap these pieces that I'm cutting out. Any other questions on this one? All right, let's try the last one on here, and that'll probably be it for today then. All right, so what are the dimensions of an aluminum can that can hold 40 cubic inches of soda and that uses the least amount of aluminum? Assume the can is cylindrical and capped on both ends. So we want to use the least amount of aluminum. What that means is I want to minimize the surface area. Okay, if I want to use the least amount of material, what I'm trying to do is minimize surface area. Okay, so this is our picture, right? This is our cylinder. And I want to minimize the surface area of the cylinder. Well, if we remember, okay, surface area of a cylinder, I'm just collecting all of the pieces. So the top and the bottom are just circles. Right? So I'll have pi r squared twice. So I'll have 2 pi r squared for both the top and the bottom. And then the lateral area is just a rectangle. Okay, if I unfold the cylinder, this would just be a rectangle where we'll denote the height with h, and then this side of my rectangle is just the perimeter or the circumference of the circle, which is 2 pi r. So my surface area, which is what I'm going to try to minimize, okay, because I'm trying to minimize the amount of aluminum, is the top and the bottom, so 2 pi r squared, plus the sides, the lateral area, so 2 pi r h. Okay, so now the other piece of information I have is that the volume is 40. What's the volume of a cylinder? Pi r squared times height. So this surface area is the one that I want to minimize. So I need to take my second equation, solve for one of the variables, and plug that in. Which variable do we want to solve for, r or h? It's probably going to be easier to solve for h, and solving for pi is not going to get us anywhere. So if we solve for h, that'll get me 40 over pi r squared. So I can now take this and plug this in for h in my surface area equation. So I can say that my surface area is 2 pi r squared plus 2 pi r times 40 over pi r squared. Now you can simplify this piece some, right? So this is 2 pi r squared plus 2. Now I've got a pi in the numerator and a pi in the denominator, right? Those will cancel. And then I've got an r in the numerator and an r squared in the denominator. So I will just end up with 2 times 40, which I'll go ahead and just make that 80. And then r over r squared, which would just leave me with an r in the denominator. But since we're going to take the derivative of this, I'm going to write this as r to the negative first instead of over r. Okay? So now I can take the derivative. So I can say that my SA prime is 4 pi r minus 80 r to the negative second. Yeah, I brought the negative 1 down. So now, set this equal to 0 and solve. So, again, when we're solving, I think it's easier to think about this as minus 80 over r squared. Now I can take this over to the other side. Say 80 over r squared equals 4 pi r. Cross multiply. Get 80 equals 4 pi r cubed. Now we're just solving for r. So I'll divide both sides by 4 pi. 80 over 4 pi equals r cubed. So yeah, we could simplify this and just make it 20 over pi. And then take the cube root. So we get the cube root of 20 over pi equals r. Right, so put that in the calculator. .853. Right, so we want, well, I guess first we need to check and make sure that that is a minimum. So 1.853 we'll put on our sign chart. Plug in a value less than that into my derivative. That's a good question. So, well, we know it would have to be greater than 0, right? And it couldn't be any bigger than, I mean, some are better, some are worse, but I mean, we could at least say it has to be less than 40, right? We at least know that our radius isn't going to be any bigger than Alright, so just try to finish this up for homework. Okay, we'll go over some more examples tomorrow. And then hopefully we'll have a little bit of time in class to work tomorrow on some examples.
Okay, I